Welcome to Chapter 7. In this chapter, we transition from examining single variables to understanding how variables work together to explain complex social phenomena. Statistics are not merely mathematical calculations. They are essential tools for answering fundamental sociological questions. Throughout our coursework, we return to one central empirical query. Why do some college students experience higher levels of depression than others? Today, we will explore how sociologists assign analytic roles to variables, establish temporal order and social proximity, measure linear relationships through correlation, and build theoretical frameworks that pave the way for causal reasoning and multivariable regression models. When designing quantitative sociological studies, researchers must clearly establish the analytic roles of their variables. The dependent variable represents the specific social outcome we seek to explain or predict. In our ongoing study, student depression serves as the primary dependent variable. In contrast, independent variables represent factors that may account for variation in that outcome, such as financial stress, self-esteem, or sleep quality. It is crucial to remember that labeling a variable as independent does not automatically prove it causes the dependent variable. Establishing genuine causality requires rigorous theoretical reasoning, proper study design, and careful statistical controls. To construct meaningful explanations of social behavior, researchers must account for both temporal order and social proximity. Temporal order demands that potential causes occur prior to their effects. As sociologist James Davis noted, after cannot cause before. Demographics like race and sex are established at birth, whereas college stress and depression occur currently. Social proximity evaluates how directly a variable connects to the outcome. Distal variables, such as parental education, exert indirect influence through intermediate factors. Proximal variables, such as current self-esteem or academic pressure, have a direct and immediate impact. Organizing variables along these dimensions prevents logical fallacies. Sound statistical analysis relies on rigorous measurement. Following sociologist Hubert Blaylock's framework, researchers move from abstract ideas to empirical analysis through conceptualization, operationalization, and measurement. Because abstract concepts like depression or self-esteem cannot be observed directly, we measure them using multi-item survey scales. Blaylock emphasized that measurement error severely attenuates observed statistical relationships, making real social effects appear weaker than they actually are. Additionally, researchers often recode variables into a logical quantitative scale to ensure that numeric values accurately reflect the underlying theoretical construct under study. In our study, variables like depression and self-esteem are made of multiple single items. By adding items together into a scale or index, it gives them more statistical power. Correlation analysis provides a fundamental tool for examining relationships between two quantitative variables measured at the interval or scale level. Represented by the symbol R, the correlation coefficient measures both the direction and strength of a linear relationship on a scale from -1 to +1. A positive correlation indicates that higher values on one variable coincide with higher values on the other, such as stress and depression. A negative correlation means higher values on one variable correspond to lower values on the other, as seen with self-esteem and depression. Values closer to zero reflect weak or non-existent linear associations. When evaluating multiple quantitative variables simultaneously, researchers construct a correlation matrix. This standardized table displays pairwise correlation coefficients across all selected variables. Key structural features include a diagonal of 1, reflecting each variable's perfect correlation with itself, and symmetric values above and below the diagonal. By scanning the depression row or column in our model matrix, we quickly identify primary bivariate predictors. Self-esteem displays a strong negative correlation of -0.61, Stress shows a strong positive correlation of 0.58, and financial stress exhibits a moderate positive correlation of 0.41%. Matrices offer an efficient visual summary of preliminary data relationships. While a correlation coefficient summarizes a relationship in a single number, a scatter plot provides a comprehensive visual representation of the raw data. In a scatter plot, each point represents an individual observation plotted along horizontal and vertical axes. Scatter plots allow researchers to inspect the direction, strength, and overall shape of a relationship. An upward sloping pattern of points confirms a positive correlation, while a downward slope indicates a negative relationship. Crucially, scatter plots reveal nonlinear patterns, subgroup clusters, or extreme outliers that a single correlation coefficient might conceal, ensuring that researchers do not misinterpret complex bivariate structures. In his classic text, The Logic of Causal Order, sociologist James Davis emphasized that statistical software cannot compensate for flawed research design. As Davis famously noted, no algorithm can yield valid answers if researchers select incorrect variables. Causal thinking requires adhering to 4 core principles. 1. Statistical results describe probabilistic tendencies rather than universal individual outcomes. 2. Social phenomena are multi-causal rather than driven by a single factor. 3. Correlation alone never proves causation. And 4. Observational studies must always account for potential unmeasured confounding variables. These principles remind us to combine statistical evidence with rigorous sociological theory. Sociologists organize hypotheses into conceptual causal models that diagram pathways between variables. For example, parental education may influence financial stress, which elevates academic pressure, lowers self-esteem, and ultimately increases depression. However, real-world data collection is inherently incomplete. Unmeasured variables, such as genetic predispositions, personality traits, or unobserved childhood trauma, can distort observed relationships and produce spurious correlations. Because no single study can capture every relevant factor, researchers must view causal models as testable theoretical frameworks rather than absolute proofs, remaining vigilant about omitted variable bias when interpreting statistical associations and observational data. In Chapter 7, we achieved essential learning objectives, defining independent and dependent variables, applying temporal order and social proximity, interpreting correlation coefficients and matrices, inspecting scatter plots, and applying James Davis's principles of causal logic. However, bivariate correlation only examines 2 variables in isolation. In the real world, social outcomes like student depression are shaped by multiple interlocking factors simultaneously. In Chapter 8, we take the next logical step by examining conditional relationships through multiple regression. This allows us to test whether a relationship between 2 variables holds true after controlling for key third variables like sex, age, or socioeconomic background.